Okay, and we're back and running on this mustard example again. So we've gone through in the last video about how to do the simple effects analysis by soil type, by variety, running two key mean separations in each of those cases. Of course, if it were appropriate, rather than running a mean separation test like that, you could use contrast for group comparisons or for trend analyses. So all of those techniques still hold. The only difference really is that you are running all of that analysis on subsets of the data rather than the full data set due to the fact that the interaction exists. What I'm going to show you now is how to visualize those simple effects through the generation of interaction plots. And the way you do that is using a package called HH. This is a data visualization package. I think the author's last names were started with an H, the two last names, so it's a big bump shout out to those guys, I guess. So the HH package, you're going to install that and then load it. This package causes some problems for some folks. It has a lot of dependencies. It requires that your R commander be up and running. And so on a PC, you may have to hunt around a little bit if R is giving you some errors to chase those down. On a Mac, you will need your whatever X11 developer software, in order to install it. But hopefully you can get through all that and get that library installed. And once you do, there's a function within that library called int_xplot, so interaction plot. And the syntax is pretty straightforward. It's your response is explained by one of the factors. So these interaction plots are intended to visualize two-way interaction. So you're dealing with two factors at a time. So you're going to have response being explained by one of your factors, and this is the factor that's going to show up on the x-axis in your plot. And then use this groups function equaling your other factor. So what this means is that there's going to be a line in the plot for each of the levels of your grouping factor. Specify the data set. This SE equals true. This turns on the standard error bars within the interaction plot. You can specify the limit of your y-axis, and for that I just put in what the range is of my response variables. You can just put the range, refer to the data set, and refer to your response. So that's going to customize the extent or the range of your y-axis based on your data. And then there's this offset scale function, and what that do is it's going to slightly it's going to offset the standard error bars a little from group to group so that they don't overlap completely, and you can actually see their ranges a little bit better, and I'll show you what that looks like. So I'm gonna load my HH package. You can see all these required packages that are loading, and it is now, wow, it's actually launching something else on my computer. It launched my X11 developer package, but it seems like it got all through. So we are loaded at this point, and I'm going to run my interaction plot. Let me open up my plot window here so we can see it a little bit better. Here is the interaction plot. Make it big. So as I was saying before, variety becomes what's on my x-axis, and now I have three different lines, one for each group. And if you can see here, I don't know if it's showing up all that well. I'll make this even bigger. Showing up all that well. You see how the blue error bar line, the green error bar line, and the pink error bar line are not exactly on top of each other. There's a slight step. That's what that offset function is doing. So that's actually allowing me to see what the full extent of my error bar is for each line, each group, even though so they're not right on top of each other. But what we can see here is that indeed it looks like soil number 3, this guy, is behaving quite differently from the other two soils. And we saw that in the F-test. If you were to look across all varieties for soil type 1, these error bars are all overlapping one another, so I really can't see differences among varieties. Same with soil type 2, but for soil type 3, it looks like variety 5 is acting quite a bit different from, say, varieties 1 and 2, and it's that difference we were picking up in the simple effects analysis. Of course, we could run the interaction plot the other way around, putting soil on the x-axis. And if we do that, now we see the 3 levels of soil. And now up here, we have 5 lines. Variety 5 looks to be acting quite a bit different from the other varieties. We have these actual crossover interactions happening around soil 2 for variety 5. So it's not the case that all the varieties are behaving, it's not the case that the relationship among varieties is uniform across all soil types. We actually have a crossover interaction happening in one of the soil types relative to, say, another one, which is just evidence again that we have to characterize variety performance soil by soil rather than speaking in any kind of general terms. That's about it for interaction plots and how to generate them. Like I was saying, the difficulty is actually getting this HH package to install. Once it's installed, the interaction plot function itself is quite intuitive, easy to use. Finally, at the end of this script, I have a template. If you're interested in, since we're talking about visualizations, here's a template for making a bar plot of the main effects using another function, tapply. So this is not something that is required at all, but I'll run through this. What this is going to do is grab all my means, grab all my standard deviations, and grab my sample sizes and standard errors, and I can create a bar plot. And you see it right here. So the way R works with a lot of these visualizations is that you create a plot that is often very, very stripped down, and then you follow that plot creation with other things that allow you to add to that. So here, starting in line 87, I'm going to pimp this bar plot. First of all, by putting in my, here, I'll just run this and I'll show you, it'll be easier. So by running this, I've done a couple of things. You'll see, first of all, that my colors changed. By using this color, I'm able to assign different values, different gradations of gray to my different bars. I can adjust the limits of my y-axis. I put on some labels, and that's about it. Now, if I want to put error bars on here, I'm going to use a function arrows, which is going to put some lines on my plot. And this is this mids, where I created this mids object and assigned it the bar plot. This is kind of a 1-2 punch where you create this mids and then you can call on this object within the arrows function. So I'm going to create arrows that have this length. It's going to go starting from the mean yield minus 2 standard errors, and it's going to go mean yield plus 2 standard errors. This is going to give me 2 standard error bars. And when I run that, it throws them on there. And then I can add text to the plot as well. And maybe if I want to put how many individuals were in each sample group. So I put this here. This is just a template for how you would create bar plots like this. And so you should feel free to just use it that way. You know, you would be basically changing where the data is coming from, but overall, the overall template stays the same. Again, that's just if you're interested, it's there for you. The code is there. All right, and we'll pick up in the next video with the next example.